Welcome everyone on today's Cubics webinar. I'm Balin from Cubics Institute of Technology and will be your host today. I hope you can hear and see us. If not, please drop a comment below. Today, we are going to talk about cloud native development, and the aim is to demonstrate that despite the challenges of cloud native applications, new tools can simplify developers' work in the long term. Our professional guide today will be Csendes, who's been using Kubernetes since 2019, if I'm right. And in the past few years, he's been playing a leading role in the developing of automating the deployments of complex applications to the cloud. David, thank you for joining us today. How are you?
Hello, everyone. Thank you. I'm fine. A bit nervous, but I'm fine.
Lovely. Can you tell us a bit about today's topic and what can we expect from this session?
Absolutely. So, because cloud is an absolutely growing trend in IT, developing applications that can run in the cloud is even more and more important. And when we develop applications that are designed to run in the cloud, then we have cloud native applications. I will talk a bit about this theory stuff at the beginning. But other than that, I will showcase some tools that one developer might use during a cloud native application development cycle, because obviously in 40 minutes, it would be impossible to show everything. But so I will try to guide you from running your application locally or deployed it directly to a server to running it kind of in the cloud.
So from zero to hero, as it's possible. Awesome. So before we start, a few more operation detail for our audience. You can ask questions in the comment section anytime during today's session, and we are trying to answer every one of these questions. And you can rewatch this webinar on Cubics Facebook and YouTube channel. So if you're in a hurry, don't forget to subscribe. Okay, so David, it's your time to shine. Let me share your screen and I will get back at the end.
Thank you. So, cloud native application development. Before we get to that, first, we should talk a bit about DevOps, the DevOps methodology. It is an IT methodology that tries to connect the developers and the operations side in order to speed up the IT processes. Now, the key here is that it will have a tight, or at least a more tighter coupling between these two sides that might work previously in a, kind of like in a silo. And they will have stronger feedback between each other, even at the earliest stages of development. And one of the key elements for this is automation. So, for example, building, deploying binaries, testing these, releasing, deploying, and monitoring, all these should be as automated as possible. And this is how we can get to continuous integration and continuous deployment. And because DevOps is trying to get more speed in our processes, it is easiest to use with smaller applications. And with that, we can get kind of like in the direction of microservices. So why is DevOps useful for us? In agile development, which is also closely related to all this stuff that we are talking about today, it requires high speed. And the easiest to achieve this is with the help of the DevOps methodology. And when we use CI/CD processes, then we can release anytime, any version of the software that should work if we did everything correctly. And because the key element, one of the key elements here is feedback, because we have strong feedback and quick feedbacks, then it is easier to notice bugs and then fix bugs than in other methodologies. Okay, so we had the DevOps. Let's talk about the cloud itself. Now, there are numerous definitions for the cloud, but one that might be really simple and we can use it today is that we are trying to use a computation capacity or service of a provider. Now, this service can be really any type of service, really, starting from simple conventional virtual machines all the way up to complete software packages like an Office package like Microsoft 365 or Google's Office suite, or even we can manage to use some stuff that we couldn't really create on our own, for example, some AI service. And this, so most of the time when we talk about cloud, most people think about that, yeah, there are the Google one, the Amazon one, Microsoft's, and so on and so on. But in reality, these are public cloud providers. Anyone can use them. But a company's resources can also be handled in a private way and shared between projects and so on. So even a company itself can create a private cloud. And we are getting close. So we try to use cloud and DevOps together. Now, DevOps has a requirement of speed, and it will speed up our processes even more. And this requirement can be handled easier with the help of the cloud. For example, we get a huge load instantaneously. Then in cloud, we can easily scale out and have more resources available instantly. With the help of the cloud, we can easily reproduce different environments that are almost identical between development, test, and production. So we can expect that there shouldn't be any surprise when we progress with our deployments. And the cloud is also useful in terms of DevOps, that from the cloud we can ask for specific runtimes, platforms already prepared for us. So in this case, we don't have to know anything about how to install these, how to connect these services together. We just get the platform itself and we can use it instantly. So our job is only to have the application delivered there. So all these really help DevOps' speed to have even more speed in the end. And then we have the cloud-native applications. Now, a cloud-native application is an application that was designed to run in the cloud, utilizing all the advantages and all the tools that can be found in the cloud. Now, it is not necessary to use this or create them with DevOps, but it is recommended at least, because we can use stronger automation. We see that DevOps is really good with the cloud and so on. And also, it is easier to develop these with smaller applications. The cloud is really good for distributed architectures. So yet again, here we are closely related to microservices. And with the cloud-native applications, we can have advantages like scalability, traceability, resilience, and so on. Now, when one might search for DevOps tools, you might get a really, really big chart like this. Or sometimes they represent these with a periodic table. And this is even an older chart, for example. Now, you don't have to be afraid because of this. So don't run away just because you see so many tools. If you're a developer and you get to this DevOps stuff and even a cloud and get to the cloud-native applications, what does this mean to a developer in the end? So we can see that we have a bunch of new tools for DevOps, for the cloud, for cloud-native applications, and so on. This can be tiring and challenging and might be create some fear in some, but in the end, only a subset of them must be known, and even less will be used in the long run. So for example, I know only a few tools, but I know a tool in each set that an application will go through. And you don't have to be afraid of these tools because in the end, they are there for helping us, for example, during debugging. Now, the applications must be written differently because we are going to the cloud. So if we think about cloud native, we should design our application to run in the cloud. But modern frameworks and languages absolutely support this kind of application writing. So if we work with them, probably there are no major things to change. And for example, if we already develop microservices, we don't have to modify anything. We only have to put in some extra development, but our application is otherwise fine. And yeah, I just only got used to Agility or Scrum or something like that. That is already tiring, but it is good to adopt DevOps and using the cloud, because using automation, we can make our lives easier as a developer. And in the end, when we are trying to be agile with DevOps by using the cloud, we can do agile even better. So today I will have a little showcase, and for that I have 2 example applications. What we're going to do is, I'm the little person, I will send in a message to a Spring Boot application, an API application, I will refer to that like that, that will simply call to another application, a DB application, to store this message and query the previous 5 messages. The DB application handles this storage, so it is connected to a PostgreSQL instance. From there, it queries the messages, and also it stores the messages there. Okay, now, so first of all, we're going to need a PostgreSQL instance. And let's start our application, our API application first. And then let's start our DB application. Now, this is just a script to run these applications locally. So I already have them built. And this time I just run it through simply Java. It runs directly on my host machine. I have some configuration here. Okay, this is for showcasing. This is the classical deployment that, okay, we have a built binary, in Java's case, a built jar or a var or something like that, and we will deploy this to a server where it will run directly. Okay, so the DB application, from the DB application, we can retrieve all the recent messages. We have currently none. We can create new message directly in the DB application. We can see that it was indeed created. And when we call the API application, I will send in a message that will be stored and also later queried. And also for something little exercise in the API application, it will add these 2 numbers together. So in the reply, I'll have the previously sent message that I sent in directly to the DB application. I have the message that I just sent in right now. And I have the result of these 2 numbers adding together. Okay. Now the next level, when we are going to we are targeting the cloud, is to use containers. Now, what is a container? Maybe the easiest way to talk about it without getting too much into details is if I try to talk a bit about its origins. So why are containers used during shipping, international shipping? When they are loading all the cargo onto a ship, if there are no containers, they have to know about which items can be stored besides another one. So for example, one might damage the other because of some chemicals or some physical stuff, damage, and so on. This is a knowledge that must be taken care of. Now, if they use containers, all the items are technically hidden away, but the containers themselves can run or can be shipped beside each other, and they can be taken travel through the world. For those who handle the containers, they only have to know about how to handle containers, not the stuff that is inside them. So kind of like we uniformized what we try to ship. And in IT, this is a similar case. So if we try to deploy an application to the cloud, it is a question that's, okay, which runtime can it run? Which version will it use? And so on. But if we create a container, we can package in our binary together with its runtime, with its dependencies, with all the version that is needed, and it can be run instantly. So for example, the API application will be run like this. I use Docker on my computer right now. I will create a container named API. I will put it in a separate network. I will connect to its shell that will be started, or its terminal. It will be removed after using. I have some port forwarding into this network, and then I have a configuration how to reach the DB application, and then the name of the image that will be created, from which the container will be created. Okay, and similar stuff will happen with the DB application too. Okay, and yet again, let's try out with the DB application, get the recent messages. We can see that because I run, well, I cheated a bit because previously I ran the PostgreSQL in a container already. So I just have a similar container running, and it uses the same persistent database. So I have the previous messages here. I can yet again create a new message directly in the DB application, and I can use the API application for putting in a message and retrieving the previous ones, and also adding these two numbers together. Now, we've seen that if we try to run this whole setup together, we have to create separate scripts for each of these and start them one by one. Obviously, this can be scripted into one large script. But because most of the time, if we use containers, especially in the development, and especially with microservices, then we might run into the case that, okay, we have to start up several containers. For example, I right now work in a project in which the application or the microservice I'm working on has kind of a lot of dependencies. Some are handled by us, so we build them, and some are like the PostgreSQL that we do not build them. They are already created by someone else or handled by someone else. And obviously, we can try to start them up one by one with a script, but Docker has a feature called Docker Compose, which requires only one file, Docker Compose in a YAML file, in which we can describe all the containers that I want to start up. So here I will start up the PostgreSQL instance. I have the image set up, I have the configuration, and I have the persistence configuration here too. I will start up the DB application with the image and with the configuration. I will start up the API application with the image, the configuration, and also a port forwarding, so I can call it with Postman later on. So if I just put in Docker Compose up, it will be created, and it will start up all the containers at once, and I can stop them at once. And it is also really nice that it will cross the logs together. So for example, if I send in that, yeah, right now I'm calling from the compose for the Docker Compose, then if we take a look at the logs, we can see that first we have the API application. It acknowledges that, yeah, a request has arrived. Okay, now it calculates this really complicated adding of two numbers. And then it creates a new message to the API of the DB application. Now, the DB application has some Spring Boot initialization, and then it says that, yeah, I had a request that arrived with this message. Then it creates a new message that was successfully created in the database. Then the API application comes and, okay, I want to retrieve the recent messages. And then comes the DB application. Okay, we have a new request, getting the recent messages from the database, and I will send back this response. And then the API application also sends back the response to me, to my Postman. Okay, now that was okay. Let's get to the next level, which is when we enter the cloud. Now, Docker was a really big step in IT towards the cloud with this containerization philosophy and, well, popularizing the container philosophy. But when it launched, it missed some really essential features. And even by today, most of these are now in Docker, but still, if we go into a production-like environment, most of the time we won't find Docker there. We will find something else. And for example, one use case is, imagine in production, obviously you will need more servers than one. Let's call them nodes. And these nodes run together in a cluster. And when I try to start a container, most of the time, I don't really care where that container will run, on which node. The only thing I care about is that container will run, and obviously, somehow the network should handle that when a request comes in, then that request will be routed to, obviously, to that node that has that container. So this is one example for which the container orchestration was created. And, well, the de facto tool for container orchestration is Kubernetes. Now, I have a Kubernetes little cluster running on my computer with kind. And what I will do is I will communicate with the Kubernetes cluster. For example, I will start a PostgreSQL instance. And as you can see, I created a persistent volume. So whatever I will do will be persisted. A service is a network object that will handle exactly this stuff, that it can handle or hide away that, okay, the containers might be on separate different nodes. And with the deployment, I start a container. Now, these are created from YAML files. Everything in Kubernetes can be represented as a resource, and resources are most of the time represented as YAML files. Now, let's take a look at the API applications descriptors. First, let's install this. Here we have also an ingress, which will route requests outside from the cluster in the cluster. So let's take a look at the deployment YAML file. And yet again, we will see some really similar stuff that we've seen with containers. So we have a deployment. Okay, we have some metadata, which helps us filtering or differentiating between each resources. We have a setting that, okay, this container must run with one replica. I can set up more, so then more containers will start from the same image with the same configuration. This is good for redundancy or load balancing. There are some other stuff here. Here I have a template. In the background, Kubernetes handles pods rather than containers, and one pod can contain multiple containers. But when we develop stuff, most of the time we have pods that run only one container. So in this template, I described that, okay, containers, we have only one. This is list, but it has only one item. And here we are. Yet again, we have the configuration, the image name. I also have some quality of life stuff. For example, probes, which will check whether the application is running and can it handle traffic. And also I have setting for ports and resource limits, and so on. And this is similar to the DB application. Let's take a look at the service for the DB application. Here we can see this is a network object. It has similar metadata, and it describes which ports it has, which ports it exposes to other services. So for example, we have that the 8080 will be redirected to the HTTP port that is called in the deployment. Now, let's try this out. Obviously, something went wrong. Let's check it. So, let's take a look at our pods. Something went wrong there, or something didn't start yet. Okay, no problem. Now it is running. So it also said back that hello from Kubernetes. Now I don't use the same persistent volume as I used only with Docker. So this is why I don't have the recent messages that I put in the previous examples. Now let's uninstall all this stuff. By the way, kubectl is a really handy tool. With that, I can communicate with the Kubernetes cluster. All the scripts I have here are simply using this kubectl. And now let's get to our final step, which will be using Helm. Now, yet again, I didn't show it, but if we take a look at an example of these scripts, we can see that, yet again, I created a script which handles multiple commands. So here I say that, okay, Kubernetes, apply this file to the Kubernetes in this namespace or project. Now, I had to do this 3 separate times for the PostgreSQL, for the DB application, for the API application, and technically I ran in something like 9 commands. Now, but I want to handle these applications and their other objects, like network objects, together. They belong together. And one tool that can help us is Helm. Helm is essentially a package manager. And this is, for example, one package. The package consists of templates. And in this template, or in this folder, we can see that we have template for the API applications, deployment, ingress, service. We have also some other tooling help. For the DB application also, we have the ingress and so on. I don't have the PostgreSQL set up here because this is a package manager. It enables us to use dependencies. So in my chart, these are called charts or packages, Helm charts. This chart is named webinar, and it has a dependency of a PostgreSQL Helm chart with a version of this and from this repository. So because of this, I don't have to create my PostgreSQL descriptors by myself. I can use someone else's and just pull it in. I can use it like this, that I define it as a dependency to my chart that I created, or I can do it in a way that, okay, I simply just pull down that chart and simply deploy it directly. Now, the templates are interesting because as they are templates, they are stuff to put in them or replace them. They have placeholders. So for example, Helm will fill in the metadata for us based on what I will call my Helm release. When I deploy a Helm chart, it will be called a Helm release. I can set up the replicas easily. I don't have to manually override it in the template file. and so on and so on. This is this uses Go templating language, by the way. So if you're familiar with Go, then you're in a treat here. Now these placeholders will be replaced based on this values YAML file. So for example, here, as I said, I don't have to create any PostgreSQL descriptors. I only has to parameterize them. So here I say that, okay, this Helm chart has these variables, and I set these values to them. I also have a resource limit for it because my computer is trying to run all this stuff together. And also I enabled metrics, which I will showcase later. And then I will have configuration for the API application 2, for the DB application, also common Spring Boot configuration, and so on and so on. Now, I can deploy it. I can deploy this with a simple command like this. Okay, Helm, please upgrade this release, or if it's not there, then install it as called webinar and from this folder. But what I will do is, to showcase something interesting, is that I have set up a GitHub Actions workflow for this. So what it is doing now, this is continuous deployment, by the way, or continuous delivery, rather, because I created this manually. So what this does is I have an agent running on my computer that is connected to the GitHub servers. And when I push the button that, okay, deploy this to my local kind cluster, then it signaled my agent, and my agent started putting out the commands that I set up in my GitHub Actions description. So here we have it, GitHub set up a job. It runs some checkouting actions because it is stored in Git. And then I have the Helm deployment. And we can see before that, it ran a Helm dependency update. So it pulled down the PostgreSQL chart, and then it ran the upgrade command that I just showed you. And it worked fine. It created it. Let's check it. Let's show all the pods that are running, and they are running indeed. Super. Okay, and let's call this again. We are now calling it from Helm. Great, it works. Okay. So it works wonderfully. Great. So this was the first part of the demo. The second part will be about some cloud-native tools. So I also have on my kind cluster or Kubernetes cluster a Grafana installed. Grafana is, well, it's kind of like the de facto visualizer tool for monitoring our applications. It is a visualizer tool that has some extensions, other tools that it can work together with. Grafana is a really popular tool. So if you will work in a cloud-native environment, there's a huge chance that you will use Grafana sooner or later, or some other tool that is really similar or similar to Grafana. I also have here set up, for example, Prometheus. Prometheus is a tool that will pull metrics out from my applications. So for example, if I look for the service of the webinar API application, I will see that I have a few metrics that are numbers about my application. If you're familiar with sport, then this is kind of like in sport when you have telemetry. There are numeric data, and based on that numeric data, you can have forecasting. So for example, in football, how a player might perform later on during the match. Or you can have feedback later on that, okay, this player didn't perform so well during the game because of some metric. So here we can have numerous metrics. For example, I can see how many seconds it takes to answer the HTTP requests. Now we can see that it was kind of slow, as you could see, that it was 2.95. If I call it again, probably it will be really quicker. Yeah, call it again. And it will refresh a bit later on. But until then, let's show something else. We can have a bunch of other metrics. We can have, for example, how quickly the application started up. We can have metrics about how long some number of requests take. For example, we can also have data about the runtime itself. In this case, we are running Java, so we can have data about the garbage collector, how much memory currently the JVM uses, and so on. Now let's take a look. Yeah, it refreshed. So we can see that it was 2.95. I called it 2 times, and it rose to 3 seconds because those 2 requests were only about 20 to 30 milliseconds long. Now, Prometheus is one cloud-native tool. It is also kind of like a de facto tool for open source cloud-native technologies for metrics recording. It is also good for alerting. So for example, if I would say that in the previous 5 minutes, about 50% of my requests took longer than 2 seconds, then I can create an alert that says, okay, something is off, please take a look at it. And that alert can be sent to a tool that then can propagate this to a lot of people through a lot of tools. For example, Microsoft Teams, Slack, it even can call you if you configure it well. Another tool that I will showcase is Loki. Now, Loki is not really a de facto tool, but it is closely related to Grafana, so it was easy for me to install it. And in the end, it is really similar to the de facto tool that is the ELK stack, or Kibana, or Elastic, or however you will call it. So the Elasticsearch, Logstash, Kibana stack. Both of these tools have the same capability to show logs, record logs, and then you can search through the logs. Here, I will look for the webinar logs. It can show a little chart for me, what happened, and here I can see what the actual logs were. So for example, if I open up this, we can see that this was from webinar application, this was the API application in particular, and I will show the trace ID later when this was, and here I can see the message itself. It was about retrieving the recent messages from the DB applications API. I also can do a lot of other stuff with this. I can sort these, I can parse these. For example, in cloud-native applications, it is really frequent that we kind of like try to make structured logs, for example, putting in JSONs as logs, so they can be parsed easier. What I have here is a trace ID. Now, tracing is where you will take a look at how your request went through all your applications or components. In this case, when the request got into my API application, a trace ID was generated, this trace ID. And this trace ID went through all my components. It was also in DB application. If you take a look at the logs, you can see this is the DB application, but it has the same trace ID. And there are tools that can show us, okay, what was the root of this call? And right now, I will use Grafana's tool, Tempo. And it can show me that, yeah, so I had the API application. It received a request with a pass method on this HTTP pass. Then it sent a pass request to the DB application, which received it. Then it even went to saving the new message into the database, which was really quick, as you can see. microseconds. Then the API application started a GET request because it retrieved the recent messages. And then with the DB application, retrieved the recent messages from the database. Now, this is really useful, especially if you have huge microservices architecture. For example, you might, if you search for it, you might see pictures of, for example, Netflix's architecture, which kind of like looks like a huge sphere with lots of dots in them that are interconnected. So there are, for examples, where thousands of microservices are available. And then it is not so easy to take a look at, okay, I sent in a request, which services did that hit? And with tracing, I can tell that. I can see if a fault occurs, that where that fault was originated. And also, I can use this for looking at, okay, what is the bottleneck? Why is my request slow? So if I go back to the first request, which was really slow, this one, that took 3 seconds, we can see what took so long. And we can see that the API application started up really slowly. So here there was about 1.5 seconds where it just kind of spin up, I guess. The DB application was also kind of slow, and the request from the database itself was also kind of slow. So this is why the first request was this slow. If you work with tracing tools, most of the time you might find yourself with Jaeger and Zipkin. These are the most popular tools. Tempo is Grafana's tool, but it is really similar to those. Okay, that's what I was trying to show you today, how to use these tools and why these are really good for us. Thank you, Balint.
Yeah, I'm here. Thank you so much for this introduction into this interesting word. If you would like to do such application, oh, one thing before I forget, if you have any questions for David right now, do not hesitate. Drop a comment below so we can answer these questions. And if you're considering to learning these technologies in a mentored course, or if you'd like to do such application or even more complex one, join our 4-week Cloud Native Development online course, where you can master the essential skills for DevOps and Cloud Native Application Development. And at the end, you will understand the basics of Kubernetes with the support of David. So I will leave a link in the comment section so you can check out all the details, syllabus, and everything related to this course. And once again, if you have any question, then do not hesitate to contact us here. Or if you have other questions related to the course, the syllabus, or other course-related questions via email. So yeah, and also if you are more interested in the world of development, not just in Cloud Native or DevOps, don't forget to follow Kubix on our social media platform so you won't miss our upcoming events, because we have really, really interesting topics in the future. David, thank you so much for joining us today and for this really, really interesting session about Cloud Native and DevOps. It was a really, really interesting session for me. And also thank you everybody who joined us today. Don't forget to subscribe again, and I wish everyone a wonderful day and see you in the next one. Thank you. Bye.
Bye.